so there have been some questions about some of the more complicated ideal gas law problems. So let's take a look at how to solve for mass or using mass when using the ideal gas law. Okay, so let's look at one of the problems. What is the mass of ammonia in H3 that occupies 0.050 liters at 700 kilopascals at 30 degrees Celsius? Okay, so there are a few things that we need to fix about this problem. Okay, so we still need to write down our variables P, V, N, and T. Okay. Now, let's just write down what we know. I know that it occupies 0.50 or 0.05 liters. Okay, liters is already in my correct units. That's fine. 700 kilopascals is pressure. This is a problem. So whenever we're using our R value, we need it to be in atmospheres. So we're going to have to convert kilopascals into atmospheres. So 6.91 atmospheres. Okay. Our T value, 30 degrees Celsius. Got to change that to Kelvin. And I'm just rounding it off to 303 Kelvin. So that only leaves our N value, our number of moles. Now, if you recall way back, we used to be able to relate the mass with the number of moles using the molar mass of the substance. That's what we're going to have to do here. So what we're going to have to do is we're going to solve for moles first, then we're going to multiply by the molar mass to get the mass. Okay, so let's take a look at what we have. Okay, so my equation is still PV equals nRT. Okay, hasn't changed. All right, so let's just plug it in like we would always. 6.91 times 0.050 is equal to N times 0.0821 times 303. Simplify. 6.91 times 0.050 is 0, running out of space, 0.3455. Is equal to 0.0821 times 303 is 24.88 N. I want N by itself. So we're going to divide by 24.88. So that my N, number of moles, is 0.3455 divided by 24.88. Okay. I'm going to draw a dash box around that because that's not my complete answer. Okay, I've solved for the number of moles, but I don't have the full picture here. The problem is asking for the mass. So instead of just stopping at the moles, I'm going to have to go one step further. Okay, so reaching way back, we're going to have to find the molar mass of ammonia in H3. Okay, so you're going to need a periodic table for this. Okay, so molar mass of Na. H3. Okay, so nitrogen, we have 1 nitrogen. Each nitrogen has a molar mass of, I believe, 14. We have 1 nitrogen. Okay. Hydrogen has a molar mass of 1 gram per mole. We have 3 hydrogens. Okay. Let me just make sure that my values are correct. Yes. Okay. All right. So that would be 14 plus 3. So the molar mass of ammonia, NH3, is 17 grams per mole. Now we just have one more step. We need to multiply our number of moles times our molar mass to get the mass. Okay? So I'm just going to finish this one off in green. 0.014 times 17 is equal to 0.238 grams. That is my final answer for the amount in mass. Okay, so the mass of ammonia would be 0.238 grams. Okay, so basically, if you're solving for mass, you're solving for your moles first, then you're multiplying by the molar mass of the substance.